Number one, I just realized, and I don't know whether this was not by intent, but simplicity meets innovation, that's the tagline of the thing that you've been hearing about so far, right? You've been hearing about innovation, you've been hearing about how simple it is to get started, to do things. And what I'm going to talk about is, so what does that mean, and what has it meant for you all, the community? What has it meant for the partners, for the customers? Now, usually I like to start with just telling a story, mainly to calm my own nerves. But I want to also tell you a few other things because I am the new kid on the block. All right? So, 30 years of MySQL and 30 years of me being at Oracle happen to coincide. This is the first few months of being at MySQL. And why am I over here? When I first started at Oracle, one of the folks, or as his team liked to call him, the godfather of HeatWave, we started on a project together which became Oracle Spatial. He left, and I then continued to build up the team on that product. Anyway, so he was talking about all these cool things he did. This was last year at Cloud World, and then I was talking about that with one of my colleagues, a developer on the Oracle database. And he said something really interesting, which is why I decided I need to stay forever 29, not become 30 years at Oracle Spatial. He said, for all my personal projects, he's a hacker. He participates in all sorts of things, does a whole bunch of things. He says, for all my personal projects, I use MySQL. And I said, I got to go see what this is about. So I am going to get into this. I will be finished well in time, and you'll have lots of time for questions, which hopefully you'll have. So I want to tell you another thing about. So yesterday at dinner, I was being introduced to the folks, right? And across the hall, in fact, is Norvald talking about indexing and the optimizer and auto-indexing and things like that. So that's an example of the champagne. We drink our own champagne. That's an example of machine learning in practice. And what I'm going to be talking about is, okay, so what have we done with that to make it possible for you to also do really, really cool things? So that's Norvald, the innovator. Across from him was someone who you all hopefully are very familiar with, a colleague of Fred. His name is Scott, and he is a developer advocate, and his job is to take gobbledygook and make it digestible. Simplicity. And it was fascinating, the conversation that they ended up having about how Scott, having learned about and being, hearing about, with AutoML, you can get started really, really quickly. And then he started talking about what he was doing with his Golf League data. I'm going to come back to that in a bit and actually get to the whole point over here. Now, what is likely to happen, hopefully you'll ask questions, and I'll make some odd claims, and this is just in case I do something like that, to remind you that possibilities are not necessarily realities. If it's in the cloud and if you can actually get your hands on it, then yes, it's there. Me talking about a possibility doesn't mean it's actually there until it's actually there. All right, so the whole point of taking something, the whole point of this HeatWave I'm not going to go into it again and again. You've heard this a number of times, etc. The fundamental point, and this is one of the things that my kids have explained to me. If you don't tell me in about 20 seconds why I should listen to you, I'm not going to listen to you. So the reason you need to be looking at all of this and thinking about all of this and thinking about getting your hands on it and getting started is primarily because the plumbing is taken care of and you can focus on the task at hand, what it is you want to do, what is the problem you want to solve, what is your end goal, what it is you want to do, which is, in the case of Scott, was figuring out what exactly is impacting my golf score. We'll get back to that again in a bit. Or actually, in the case of Craig here, it's how do I use AI to churn out better blogs faster, and how do I use it to collaborate with our Oracle Aces? Isn't that right, Craig? Right? So that is the point. Use the infrastructure to do things with it. So the other thing about Norvald, the innovator, he's from Norway, and I was not necessarily great at social graces, so I figured, let's ask him about the land of the midnight sun, which I did. Now, the other people that I talked to about life in Scandinavia were folks from, Finnish police when I was working with them on spatial. Their description of life in Scandinavia was all about how in the summer they go for dinner at 10 and it goes on till 1, or the saunas and things like that. Norvald's thing was, he said, you know what? Sometime at the end of July, etc., the sun rises twice. The sun sets twice. And I figured, now that's what's meant by a machine learning mindset. That's anomaly detection. No wonder he does things like this, right? That's what it is. Find an unusual pattern. Sun is supposed to rise once, set once. In July, in Norway, on a particular day, it rises and sets twice. You all should go see it sometime, actually. Okay. So, what we do in HeatWave AutoML is make it possible for you to understand and focus on what it is you want to do. So let's take an example of that. Earlier this morning, we had all these wonderful customers up there, right? So let's say you're a financial institution. You do things such as you give out credit cards, or you want to get customers, acquire customers. There comes Scott, right on cue. Now, it may cost you, okay, this part also, that disclaimer, which was about if I say that something will be in the product, it's only in the product when it's actually in the product. This also now applies to this next part, because I am also, as you can tell, indulging in storytelling. So let's say you are a credit card company, right? And your cost of acquiring a customer is $350. There are some for whom, in fact, that is indeed the case. Not necessarily ones who use MySQL, or maybe they do. Of that cost, $150 of that goes in direct mailing. Now, if you can bet they spend a whole bunch of time on figuring out how to do target campaigns. Because if they can bring that $150 down out of $350 of the cost of acquisition, that moves the needle. That makes a difference. Now, it's costing them $350 to get you to use their credit card. You can be sure that they have predicted your lifetime value to be at $500 or more. And that is indeed what they do. How do they go about doing that? Segmentation. They figure out how to segment their user base, or their customer base. They figure out how to target. And that is what machine learning is in a nutshell, right? How to make it better, cheaper, more effective to get your business done. Let's take another example, manufacturing. So when Nipun was talking, he was talking about like how a company that manufactures chips and runs its processes on MySQL, how they reduce downtime. So one of the ways in which they do that is they're doing a lot of testing, and a lot of the assembly lines and a lot of the things is done by collecting information from all the systems, and these are all being backed by MySQL databases. Now, if any of them go down, what is the impact? The impact is either something on the assembly line stops, or some testing cannot happen in time, or something goes wrong in packaging, right? Any disruption in that has a severe impact, and so they need to reduce that. So their whole focus is on look at the state of what is going on and very quickly at least identify and preferably get notified before a problem becomes a crisis. So get notified of, okay, on this particular instance or in this database, for example, we are seeing a steady increase in the number of requests for a connection, or a steady increase in the number of, or what time space is being used up, or something is happening, and get that notification beforehand. All of that is being driven by the machine learning capabilities that are part of the platform that they are using. So the thing is, all of that is there. Now, how do you actually use it? One is, you can take all of these libraries, these processes, and you can certainly cobble this together yourself. Or you can use the AutoML pipeline that we have implemented and made available to you, that we use ourselves internally. And here's the other thing about all of this. All of these steps are integrated, tied together. The most important thing about it, the most important thing over here is that these are normally, if you look at data scientists and practitioners and when they do things with their notebooks and things like that, it is very often an iterative process. They do multiple passes over these things, and they improve on what they're doing, which they can certainly continue to do with the in-database machine learning. The difference over here is that we make this whole process a lot more efficient. How do we do that? We can certainly get into all of those details about, well, what is the adaptive sampling that's being done that makes it possible for you to do this much faster and not have to go through all of your data and not have to profile all of your data and calculate the distributions and things like that. But the more important thing is that we can do all of this in one pass and give you a good, actually better than good, a efficient, effective model that you can then use. Now, once you have that, you can obviously evaluate it, run the score and things like that. But more importantly, what we also give you is the ability to then say, okay, what are the factors or what are the features that this model is using? So ask to explain what it's doing. All right, so since Scott is now here, let's take an example of what that actually means. So when he was doing his golf league, and he was playing around with this, and he looked at it, and the first time around, he got like outstanding results, which If it's too good to be true, it's too good to be true. So he asked, what he asked it. He ran this model explainer, and he discovered that, the data contained the answers. He was giving it the dependent and the independent variables. He was giving the dependent variables too, so it figured it out that, it was predicting, how much he's going to score, but he was giving the data for the handicap and the net, and handicap plus net is your total. It figured that out, so it was obviously predicting things perfectly. And then what happened next, Scott? Go ahead.
When I removed the net score and the handicap from the data set, the results became a little bit more widespread, but it didn't really make sense. And when I ran the explain there, I found out that it was using the team name, and the teams had 2 golfers. So some of the scores were actually off because it said, oh, we're going to use the team name, and if it was a really good golfer playing with a really bad golfer, if it was a really good golfer playing with a really bad golfer on a particular team, then the bad golfer score would be predicted lower than what it should be, and the higher golfer score, or the better golfer score, were predicted higher than they should be.
Excellent, thank you. So the other point that I want to just make on that, so Scott, so once you'd got your data in, right, and once you'd figured out that you'd already given the model the answer, etc. When you actually came down to, okay, now I've got things the way I need them, I want to run this thing, what were the, A, number of steps, and 2, what were the steps? There were 3 steps, right?
3 steps.
There you go. Go ahead.
Once I had the data that I knew was going to work, the first step was to train the model, which is a call to a stored procedure, which is called ML_train. And then once that was done, the next thing I needed to do was I needed to load the model, which was ML load. It might be load model, I can't remember.
Load. It was ML load.
So it's ML load, and you pass in the model that you just created. And then the last thing I did was I called a stored procedure called ML predict table, which took data that was in a different table that matched the same structure as the data it was trained on, and then it went through and it generated the prediction for every row that was in that table.
So Scott, Sandra hasn't given me all these giveaways to hand out to folks who help me along. So here's the help for you. I'm going to do a plug for Scott's. Scott's going to do a MySQL shorts on this, right?
Yep.
I mean, if you're not, you are now, because this possibly even a blog post,
yes.
Right? So be tuned for that. He's actually going to go into a lot more really interesting things on this story. But here's the other thing about this thing. So you notice Scott didn't talk about all this other stuff on the right. He just talked about what he needed to do, identify that what he's trying to do is predict something, so it's a regression, and then that's it. He called ML train, ML load, ML predict. He didn't have to figure out about algorithmic selection, adaptive sampling, feature selection, etc. He did in a way, because the explain had to go and tell him what were the features it was considering important, so he could change things. Now here's the next thing about the lovely part about all of this stuff. Scott is now hooked.
I am.
He can do this over and over again, right? So now he's looking at this, Scott is looking at all of this data that he's got, and he decided, okay, let me throw in the weather to see if that has an impact. It actually does. You'd expect, hot, cold, rainy. Interestingly, windy. If it's windy, that is having more of an impact on his game. Anyway, more to continue in his blog, in the MySQL shorts. So this is essentially what he had to do, which is call train, that is, train the model, give the data, create a model. It goes through the process to figure out which one of the various regression models. By the way, if you know exactly which one you want to use, and if you If you're very much into all of these details, we document all of the models, algorithms that are supported. You can choose to override it and say, hey, go and use this classifier or go and use this regressor. I know what I'm doing. I know what my data looks like. I've done some of the analysis. I just want you to use this, and it'll show, go ahead and do that. If you want to ask it to compare specific ones, you can ask it to do all of that too. So while it may look and seem like a black box, it actually isn't, because we give you control to go into the nitty-gritties of it, which is what Scott is about to do, in fact. Because this is a domain that's near and dear to his heart, improving his golf score, and all of a sudden now he can keep experimenting with it. But what's the thing that actually got him hooked? Because when we first did this, we presented to him Python notebooks. And he says, sorry. He was a lot more eloquent and expansive than that. Then we said, you know what? All of this stuff that we've got, it boils down to these 3 stored procedures. And then the light bulb went off. Or the golf ball hit you on the head, one of the two. Okay. So yes, you can do that on your database tables, but you can also do that on your data in the object store. Why and when would you care about that, for example? So I'm going to do another plug. Back there somewhere, while I was walking in, I ran into there's a gentleman, Bhushan Arora, who's going to talk about this tomorrow. His talk is going to be about real-time predictive analytics or predictive maintenance. Now, what's happening over there and what he's going to be talking about, and the context here is, why would you care about lakehouses? Which was a question from Fred. Very valid question. Why do I care about a lakehouse? So what Bhushan will be talking about is, you've got data coming in from all of the sensors telling you the state of your whatever it might be, right? In his case, machinery doing something and the conditions under which it is operating, under which that is operating. And they all have, when they're reporting their current state, they're all things that are within expected range. When something's out of expected range, for example, possibly my blood sugar after all the lovely dessert, then you need to do something about it, right? And you need to know that. And you need to know, what is the likely impact? Is this a sign that this equipment is going to fail? Is this a sign that this equipment needs just a little tweak? Is this a sign that it's going to trigger something that'll hold up my whole assembly line, right? Now, all of that is coming into essentially what's known as a lakehouse. It's coming into your object store. It's not necessarily coming into your databases because, for example, let's take an example. If you are PG&E, Pacific Gas and Electric, right? For them, on a daily basis, because in California in particular, there are so many microgrids, in the sense, California really wants to use reusable energy, renewable energy, right? So you've got all these microgrids contributing to the actual grid, right? And if it's a cloudy day, you're not going to get solar power. If it's not that windy, or your wind farms are not for some reason producing, then how do you, A, know that that's happening, and B, do something about it? So all of that are not coming into a curated, filtered, ready for, they're not coming into transactional systems. Those are going into object stores on which they're operating. Yes, for later, for historical analytics, they're going into scrubbed systems. But that initial, what am I going to do if in Southern California I'm getting less solar power than expected. You still want to be able to charge your electric vehicle. You still want to be able to run your ACs in the summer. PG&E doesn't have time to react to that. They have to anticipate that, and they have to make sure that they can adjust the demand. Adjust for that difference in demand. That is when things work off of things such as Lakehouse. Does that make sense? Thank you. Thank you for that, actually. It actually made sense. Good. All right. How am I doing on time? I am doing okay. So you've heard that this is available on all the clouds, and that is true. So I just want to give you an example of, in the case of Amazon, what we do is we're able to use the console there to make this. Yes, you just have to do 3 steps, but we make it even simpler. We give you a GUI interface to interact with your data. This is something that will be soon available on OCI 2. It was just that on Amazon, when we built it, it was easy to get this done at that time. Now, I'm not going to go into, I've been talking about a lot of these use cases, etc., so I'm not going to go into all of these things. One of the ones that I want to really focus on is the simplicity and innovation part. I'm going to take an example of another customer in the LA region. Now, this is a family-run business, not AirCall. I'm not referring to these slides. I'm talking about another example. And the reason why I want to do that is the following. This was a family-run business that actually supports a lot of other mom and pop stores in Latin America that sell beauty products, right? And what they want to be able to do, they source a lot of their products, for example, maybe from China, or for that matter, from South Korea. For some reason, sunscreen from South Korea is really popular. I'm not too sure why, but it is. It takes them 3 months to get that. And so obviously what they want to be able to do is predict what is the likely requirement, what is the likely inventory that they need. And with the help of somebody else here, this gentleman, Manuel, it took them 2 weeks and they were able to get that done, and they now run it on their own. They did the project, gave them a few sample notebooks, and this family-owned business, they run it themselves for their customers. And that's the whole point, is that simplicity has given them the ability to innovate and serve their customers better. Thank you.